Yesterday we multiplied and divided, we need a screen, rational expressions. Today we're adding and subtracting them. Should be, we used a little bit of the multiplying and dividing within it. All right, which is why we did that first. So it's easiest to add and divide when you have different denominators. It's easiest to use the least common multiple of the denominators as a common denominator. So our first example, our goal is to find the least common multiple. So at this point, we're not adding and subtracting fractions yet. We're just practicing getting the least common multiple. Okay, so we're doing that first, least common multiple. So the first step is to find the prime factors of each expression. That means factor it as much as possible. Let's start with the 4x squared minus 36. Always good question to ask first. Is there something common we can pull out to the front? A 4. Okay, so if we take a 4 out of 4x squared, we're left with x squared. And then when we take 4 out of negative 36, we get minus 9 left. All right. Is 4 a prime number? No, so we got to keep going. What can we break 4 down into? 2 and 2. All right, those are prime, so we can not have to worry about those much anymore. Now we have to break down the x squared minus 9. We can keep factoring that. What are the factors for that? Yeah, it's a perfect square, so negative 3 and positive 3. If you need to think about it this way, think that the middle term is a 0, plus 0x. So you need factors of negative 9 that add to get 0, which is where we get the minus 3 and the plus 3. All right, now we can't break it down anymore, so those are the prime factors, so we're good for that one. Now we can move on to the other one. So now we're going to deal with 6x squared plus 36x plus 54. Like I said, good for the first question to always be, is there anything common we can pull out to the front? 6. We can pull a 6 out of every term. So if we pull it out of 6x squared, we get x squared. If we pull, plus 9. We basically divided each term by 6. Now a 6 prime. No, what can we break it down into?
3 and 2.
2 and 3. Those are primes, so that's good. Now we have to factor that trinomial. What can we factor that into? X plus 3 and x plus 3. Because those 3's multiply to get 9, add to get 6. So we're good. All right. Step 1 is complete. We have found the prime factors of each expression. That's supposed to say factors. All right. Step 2 says write each prime factor the greatest number of times it appears in either expression. All right. Simplify where possible. So let's see. We have lots of different factors here. Some of them are the same, some are different. So let's just start at the beginning. So like the 2, does 2 happen in both? Yes. So which in the first expression and the second expression does it happen more times? The first one. So we need to write down both of those 2's. All right. I'm just going to keep going down the line. So x minus 3, does it happen in the other expression? No. So it's just that one. So the greatest number of times it appears is once. So we're going to write it down. All right, going down the line. X plus 3, does it happen more times in the first or the second? Second, and how many times does it happen? Twice, so that's how many times we write it down. All right, so we took care of the x plus 3. So keep going down the line. The 2, we already took care of that. So what's left to write down? The 3, and it happens once total. All right, now the only thing left is to simplify. So let's see, what's 2 times 2 times 3? 12. All right, so we took care of those. The x minus 3, it's by itself, so I'll just write it down. And then the x plus 3, how can we write that a little simpler? X plus 3 squared, because it happens twice. So this is the least common multiple between those two expressions, which we could like FOIL and distribute and blah, 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 all that, but we'll leave it here. All right, so the first like 4 problems on your homework are like this, where you find the least common multiple. Now we're going to add rational expressions and subtract. We'll do adding first. So the steps are kind of on the side here, so we'll just follow them. We need to factor the denominators. So our first expression, so 1 over, what can we factor that denominator into? Has to yes, it has to multiply to get 4, add to get 5, so x plus 4 and x plus 1. All right, now we need to factor the denominator to the second. What can we do with that one? Pull out a 3. Yeah, look at what's common. There's a common 3, which leaves us with what? X plus 1. All right, now is the point where we make the denominators the least common multiple. So kind of as we go along this way, I think it's easiest to say, look at this first denominator. What does the second denominator have that this one doesn't? A 3. So we need to, we're going to write down that whole thing again. And you can combine steps on your homework. And then we're going to multiply the top by 3 and the bottom by 3. Now look at the second expression. What does the first denominator have that this one doesn't? An x plus 4. So we have to multiply the top of the second by x plus 4 and the bottom. The bottom is what we need, but in order to keep everything stable, we have to multiply the top and the bottom. All right, so let's actually multiply. So 1 times 3 gives us 3 over our denominator 3 times x plus 4 times x plus 1 plus, let's see, 5x times x gives us 5x squared, 5x times 4 plus 20x all over our denominator again, 3 times x plus 4, x plus 1. So are these denominators common? Are they the same? Yes, so can we combine these fractions? Yes, remember when you combine fractions, when you're adding them, common denominators, you just write the denominator once, and then you add whatever's on top. Are there going to be any like terms on the top between 3, 5x squared, and 20x? No, so what term should we write first? 5x squared, because its degree is highest, then 20x and 3. And there is your answer. Now we're going to do another one. We follow the same steps, but we are going to subtract them. So first off, save some room down below. What's common in that first denominator that we can pull out? 5. When we pull out 5, what are we left with? Yes, 25. Very good. All right. All right, so...
Wait, can you not pull a 3 out of the other?
Yeah, we can. You want to go ahead and do that?
Oh, sorry.
It's okay. So if we pull a 3 out, what do we get? Y plus 5 left. All right, so the first step is to factor the denominators. So we get 7y over 5 times. We can factor that y squared minus 25. What can we factor it into?
5, 5, 5.
5 and 5, what will the signs be?
Negative and positive.
Negative and positive. Good. Okay, and then the other one, we already factored it as much as we could, so we'll just write it down. All right, now we identify what's missing. So what does the second one have that the first one doesn't? Okay, so sorry, I think I said that confusing. So we're looking at the first one. What does the second one have that the first one is missing? It's the 3. So we got to multiply the top by 3 and the bottom by 3. What does the first one have that the second one's missing? Yeah, you also have y minus 5, and then there's something else too.
5.
Oh, 5 too. All right, so we got to do all that. Okay. Next step is to multiply. So 7y times 3, 21y over, I'll just simplify a little bit. What's 5 times 3?
15.
So 15, y minus 5, y plus 5. Make sure we still have our subtraction in between the two fractions. Let's see, we can do 5 times 4 is 20, and then we still have y minus 5 in parentheses. And then our denominator should be the same. 15, y minus 5, y plus 5. If we keep simplifying, we can distribute right here. 20 into y and 20 into negative 5, so we get 20y minus 100. From here, let's go ahead and make it just one fraction. So our denominator is 15, y minus 5, y plus 5. And then on top, let's see, we get 21y, and then what do we get after that?
Wait, can you not combine 21y and 21?
Yeah, I'm going to write it out so we can look at something. So what do you get next?
20y.
Minus 20y, and then what?
A positive 100.
Plus 100. Why is it plus 100?
There's 2 negatives.
Yes, because we have this negative here in the middle. So we actually had to distribute that to the 20y and the negative 100. Okay, so that's like the tricky part of subtraction is distributing that negative. So if you need to, make a star by it. So maybe it'll help you remember. All right, we're almost done. Woo, with this problem. All right, so what can we simplify from here? 21y minus 20y just gives us y